Testing 1, 2. Testing 1, 2. Earth. Is Earth there? No. Oh, I don't know who that person is. Sorry, we can't say words like that. That might like be copyright infringement. We don't want to have like voice. Like, talk to me. All right. So today, everybody, since I royally stunk it up yesterday explaining anything of how to solve trigonometric equations, we're going to try this again. Alright? So the first thing that I'd like you to do is wherever you see sine of x, make it equal to u. Interesting. Gonna highlight that. Gonna highlight this. And wherever I see this, what am I gonna replace it with? U. Looks like, by the way, just in case you don't know what the sine squared of x is, it's the sine of x times the sine of x. So, by the way, what would a u times a u be?
U squared.
There you go. Huh. Wonder what I'm going to replace the sine of x with. Now, there's a particular reason why I decided to do this, because this is a quadratic. And you all should have had algebra 2 and algebra 1, so you should all know how to factor this triangle. So if you would, please go ahead, try to factor it, see if you can do it. Put a 2u here and a u there, see if you can factor it. Okay. Alright, let's see. Emily, what did you get as the factors of 2u squared minus 5u plus 2? Minus 1, minus 2. Now let's see. What do we always check? We look at the outside products. And we look at the inside products. And if they add together to equal this, what does that tell us? So by the way, these are the products. Sorry, these are the factors. So I'm going to rewrite. But this time, I'm going to replace, wherever I see a u, I'm going to replace it with, not that. What am I going to replace it with? There we go. Put it back. Take this and put it back in here. And put it back in here. So this is what you should see. 2 sine of x. Sorry, or it's getting a little temperamental. These are the factors. Now, what we have to do now is we need to take this. And what am I going to set this equal to? 0. And then I'm going to take this guy right here. And what am I going to set him equal to? 0. Let's do it. Set him equal to 0. 2 sine x minus 1 equals 0. And then you have sine of x minus 2 equals 0. And then at this point, we're going to solve for x. So you should both know, both of you being, I don't know, just both of you, whoever that is, that 2 sine of x equals a 1. And over here, if we add 2 to both sides, you get the sine of x is equal to a 2. Here, what do you got to do to both sides? Now I have an equation I can finally finish. Because even though, I'm going to give myself some room here.
I have to do is I have to apply the inverse of sine on this side, and I have to apply the inverse of sine on the other side. I don't have enough room to put parentheses. What happens to those? They cancel out. And what are you left with? X equals the inverse of sine of 1/2. What will x equal over on here? If you just kind of skip a step, what is x going to have to equal? The inverse of sine of 2. Now, by the way, what is sine? What is sine of x or sine of theta always compare? It compares your y value to your r value every single time. That's what it compares, the y value to the r value. Now, let's go over here. Going to hit second mode. Hit this out. If I hit, I'm going to be in mode. I'm going to change it to degree mode. Changing it to degree mode right here. And I hit second sine, and I type in a 1/2. That's 30 degrees. Now, if that's 30 degrees, what is 30 degrees in radians? What am I going to have to do? Take that and multiply it by pi over 180, which gets you 30 pi over 180, which reduces to pi over 6. One of your answers, everybody, is pi over 6 radians. That's one of your answers. Because when I solve for 30 degrees, all I do is change it to radians. That's going to give me one of my answers. Now, this is what I want you guys are going to add something to your journal that you don't have, and maybe this will help you whenever you guys get to a certain point. Okay? So everybody, if you would, please, what I'm going to do is I'm going to scroll over here. I'm going to draw a unit circle, and all I'm going to do is separate it into 4 quadrants. Okay? Those of you who write this in your journal, hopefully will have a reference to help you out. Now, just remember, in quadrant 1, all the x's and all the y's are positive. Quadrant 2, the x's are negative, but the y's are positive. Quadrant 3, this is where all of you live, this is where the teenagers live. All the x's and the y's are negative. It's a very negative place. Alright? And you have the positive x and negative y. There's your quadrant 4. So what I'd like you to do, if the sine of theta compares your y value over your r value, where is it always going to be positive? Which quadrants is the sine of theta always going to be positive? Where's the y values always positive? 1 and 2. So you need to understand you're going to have an answer in quadrant 1, and you're going to have an answer in quadrant 2. Well, if the sine of theta is negative y over r, and it ends up being negative, which quadrants are you going to be living in if you have a negative? 3. So your answers are not going to be in quadrant 1 and quadrant 2. They're going to be in quadrant 3 and quadrant 4. Switching colors. Cosine of theta compares your x value to your r value. Where is the x value always going to be positive? 1 and 4. So if you're dealing with cosine and you get a cosine of x answer, guess what? If it's positive, you have 2 answers. What are the 2 answers? 1 and 4. But if the cosine of theta, which compares a, let's say, a negative x value to your r value, now your cosine of theta is negative, where are your 2 answers located? 2 and 3. And last but not least, tangent. Tangent compares y over x. And where is the y value over the x value positive? 1 and 3. Why 3? Because a negative divided by a negative is a positive. So where is the tangent of theta which compares, let's say one of them's negative. I don't know which one of them's negative. It could be the y, it could be the x. But your tangent of theta is negative. Where would your answers lie or be located? 2 and 4. Now what I'm going to do is I want you to understand that these rules right here, these rules will still apply for cosecant. These rules right here will still apply for secant. So I'm not going to rewrite them. Just understand that these are just inverses of each other, right? They're just reciprocals of each other. And these rules right here will still also apply for what? Cotangent. Okay? So I'm just not going to rewrite everything just to say the same stuff over and over again. Now, how many answers did we get on our problem? We only found 1. But wait a second. If we only found 1, we found the answer in quadrant 1. What was our answer in quadrant 1? It was what? It was pi over 6. We need to find the other answer that lies in what? Quadrant 2. So this is what I want. I'm going to leave this up here. All right. I'm just going to move over a little. Does everybody have this down? Hopefully you have it down. All right. So let me kind of show you right now with this picture. Hopefully this will be helpful. From standard position, everybody. From standard position, this was our first answer. I'm trying to make a 30-degree angle. So where are we at? We're at pi over what? Pi over 6, and there's our 30-degree angle. Where's the other place we can make a 30-degree angle? Over here in what? Quadrant number 2. So if this is 30 degrees right here, how many degrees go from here all the way across? Remember, this is from standard position. Standard position is from right here at 1, 0. How many degrees is that? That's going to be 150, because 150 plus 30 is 180. So we're at a what? We're at 150 degrees. But if I wanted to change 150 degrees, what do I have to multiply by? Pi over 180, and that reduces to what? 5 pi over 6. So what's my other answer that I need besides just the quadrant 1 answer? I need the quadrant 2 answer. Our two answers end up becoming pi over 6 gradients plus 2 pi over n, and 5 pi over 6 gradients plus 2 pi over n. I'll explain. This right here, this is the confusing part, because this is all the answers. This pattern is going to repeat over and over and over again, because in a unit circle what happens is whenever you're doing plotting points in the unit circle, it just keeps going on forever and ever and ever. So what happens? An answer hits here, another answer hits here, and I'll explain when we look at the graph. Yeah, n means revolutions. Okay. Now, over here, did anybody try to do x equals the inverse of sine of 2? Did anybody do that? Yeah. If you do that, look what happens. We have second sine. I put a 2 in there. All right? Oh. That didn't work. By the way, what does sine of theta compare, by the way? What is sine of theta actually compare?
Y.
Yeah, no. Y and what? Y and R. So can the Y value over the R value ever equal a 2? Let's think about it. In a unit circle, if you go back and look at the unit circle, what's this point right here? That point is at a 0 and a 1. So really, honestly, the greatest number that Y can equal, a 1. That's the greatest. And that 1 over, what's 1 over 1? What's Y? That's 1, right? So that's the greatest. Look what happens. If you did the sine, right, of 1. Not sine, sorry, inverse of sine. Inverse of sine of 1, what should you get? You should get a 90-degree angle. If I did the inverse of sine and I said 0.99, what do you get? 81 degrees. If I say the inverse of sine and I say a 1.1, what do you think is going to happen? It's going to get an error. It's not going to work. Okay? So understand, if you get a sine of anything and it's greater than what? It's greater than a, don't do anything. Just say, not going to do it, no solution. So we only had 2 solutions. What were the solutions? Pi over 6 and 5 pi over 6. Now, I'm going to explain to you guys how this works. So I'm going to go to quit, right here. And do you guys see this formula right here that I've typed into the graphing calculator? I'm going to go and do it with you one more time, okay? It's a 2. You're going to open up the parentheses. You're going to type in the sine of x, close parentheses, you're going to square. By the way, in the graphing calculator, the sine squared of x, you can't write in the graphing calculator. You have to do the sine of x squared. So you have to type it in the graphing calculator like this. They mean the same thing. All right? So after you do that, then you can hit, is it minus 5 sine of x? And then is it minus 1 or plus? Plus 2. Plus 2. Now where do we want this graph to equal? We want it to equal where? 0, right? So check this out. Go to your window. What I'd like you to do is go from 0 to 2 pi. We're just going to go from 0 to 2 pi. This is where it's going to be tricky. By the way, what was our first answer? Our first answer was pi over 6. So make the x scale pi over 6. And it'll make more sense. So make your x scale pi divided by 6. You can keep your y minimum -5, your y maximum +5, your y scale 1. Now look what happens when I graph it. Oh, you know what? Got to change my mode back to radian mode. My bad. That's not going to hold on. Change the mode back to radian mode, otherwise the graph won't be functioning. Press N. There we go. So my answers are right here and right here. So where am I right here? This x scale is at pi over 6. Where am I at? Pi over 6. Where am I over here? I'm at 5 pi over 6. Are there any other solutions between 0 and 2 pi? No, there's not. So what about plus the 2 pi n? Technically, this will continue to go on forever. So watch what happens if I extend this out. If I extend the window, and I don't start at 0, but I end at, say 16 pi. That's like 8. That's right, it's 4 revolutions, right? 16 pi. So every single one of these, that's pi over 6, that's what? 5 pi over 6. And then this is pi over 6 plus 2 pi. And this is 5 pi over 6 plus 2 pi. Okay? And then this is pi over 6 plus 4 pi. And this is 5 pi over 6 plus 4 pi. So, but it just keeps going on forever. Yeah. Okay? So, by the way, that's why I just changed it to 2 pi so you guys can see those 2 solutions. Alright? So these are the only 2 solutions, right there and right there.